this video, we'll talk about how to set up a word problem in algebra. We'll talk about some very common forms of word problems and go through several examples. So by far, the most common word problem structure you'll run into in an algebra class is the idea of blank plus blank, sometimes plus another blank, equals a total. So a number of blanks adding up to a total, or blank minus blank equals some kind of result. So either we're adding a number of terms or we're taking one term minus another term. Let's see how this structure fits example 2. The sum of 3 consecutive integers is 132. What are the 3 integers? So the word sum refers to addition. Summing 3 things means I can set this up as blank plus blank plus blank equals a total. Now I have to decide what to put in each blank and what the total is. Well, the easy part is the total. The sum is 132. So I'm going to put that the total is 132. But what am I going to put in each of these blanks? I don't know what any of the integers are. I don't know what the first one, the second one, or the third one is, but I could start using variables. Since I don't know the first term, I'm going to call it x. Now the next consecutive integer, remember that integers count by ones, so the next integer is going to be 1 up from x. I could represent it as x plus 1. So in the second blank, I'll put x plus 1. The third integer is 1 up from that. So x plus 1 plus 1, or x plus 2. I'll fill in the third blank with x plus 2. Now x plus 1, and x plus 2 represent consecutive or integers that follow one right after the other. Now I've got an equation to solve. Let's see if we can solve it. There is no distributing to do, but I do have some like terms to collect. X plus x equals 3x. 1 plus 2 equals 3. So the left side is 3x plus 3. The right side is 132. Let's start undoing things. There's a number being added onto the variable side. I'm going to subtract it to cancel it out. So subtract 3 from both sides. These add up to 0. So what drops down is a 3x. 132 minus 3 is 129. Now there's a number being multiplied times the variable. I'm going to get rid of it by dividing. 3x divided by 3, all that drops down is that x. And 129 divided by 3 happens to equal 43. Now we have to go back and look at and see if we've answered this question. It says the sum of 3 consecutive integers is 132. What are the 3 integers? Well, I only have one answer here, but notice that each blank is going to contain one of the 3 integers. So the blank x, that's my 43. The blank x plus 1 is the next integer after that, 44. And the blank x plus 2 is the next integer after that, that's 45. So the 3 integers they're asking for are 43, 44, and 45. Let's take a look at another problem, another consecutive integer problem. This one has a few variations to it that the first one did not. Move this picture here out of the way. The sum of 3 consecutive odd integers is 57. What are the 3 integers? Well, it kind of sounds like before. A sum means I'm adding up things, and I have to add up 3 things. One thing plus another thing plus another thing to equal 57. My total this time is 57. Now, again, we don't know what any of the integers are, so I could certainly represent the first one with an x. But notice that this says consecutive odd integers. Odd integers are 2 apart. 3 is 2 away from 1. 5 is 2 away from 3. 7 is 2 away from 5. So as I work my way up the odd integers, I need to jump by 2. My second integer will be 2 more than the first one. My third integer will be 2 more than that, or x plus 4. So I'm going to put x in one of these blanks. I'm going to put x plus 2 in the second blank. I'm going to put x plus 4 in the third blank. I'm going to combine like terms. X plus x plus x gives me 3x. 2 plus 4 gives me 6. And the total, as we said, is 57. All right, 2 steps can solve this equation. I'm going to subtract 6 from both sides. That takes care of this number being added onto the variable side. And a 3x drops down. 57 minus 6 equals 51. And dividing both sides by 3. I get that x is equal to, and then 51 divided by 3 is 17. Again, I haven't answered this question completely because the question was, what are the 3 integers? That's only one answer. That represents the first odd number. The next odd number is 2 away from that, and it's 19. And the next odd number is 2 more away, that's 21. So my complete list of integers, odd integers for this answer is 17, 19, and 21. Let's look at a slightly different kind of problem, but it still follows the basic format of a blank plus a blank equals a total. This is what's called a mixture problem. And you'll see these kind of problems where they're mixing different kinds of fruit juices or mixing acid, and you have different percentages, different concentrations of acid that you want to mix together. So a lab technician needs 25 liters of a solution that's 15% acid for a certain experiment. But she doesn't have that kind. She only has a solution that is 10% acid. Well, that one is too weak. And a solution that is 30% acid. Well, that one is too strong. We need to mix this together to create 15% acid. The question is, how many liters of 10% should she use? And how many liters of 30% should she use? She'll mix them together and hopefully wind up with 25 liters of 15% acid. Well, in any mixture problem, you're going to fill in these blanks with a product of a percent times an amount. Let's start with the total that she's going for at the very end of the process here. She wants a percent that is 15. We're going to put that in our equation as 0.15. And she wants an amount that is 25 liters. All right, that's our goal. 15%, and we want an amount of 25 liters. But what is she starting with? One blank is going to have 10% acid. You can certainly put a percent in there. Notice that I'm always writing these percents as decimals. That's important in a mixture problem. But I don't know how much she's going to need of that. Just like before, when I don't know how much, I'm going to use a variable. So let me put an X there. And then we've got to figure out, what can I fill into the next blank? Well, certainly I know the percent. 30% is the other kind of acid that she has to work with. So 0.30. But how much is the amount? I don't know that either. I can't use X again because that would imply that it's the same amount of both kind. I don't know that yet. Maybe it's more of one kind, maybe it's more of the other kind. I can't use a different variable because we haven't learned to solve equations that have 2 variables in them yet. We're just solving equations that have 1 variable. So let's see if we can reason through this. If let's just kind of experiment. If she uses 1 liter of 10%, then all the rest is going to have to be 30%. So 25 is the total. 1 liter here would be 24 liters here. If she uses 5 liters, 10%, that only leaves 20 to use here. Because remember, it has to total up to 25 liters. If she uses 15 here, that only leaves 10 for her to use here. Always this X and this other number add up to 25. Here's how I can show that. I'm taking this entire 25 liters and I'm going to divide it into one amount that is X and one amount that is 25 minus X. So 25 minus X is always how I figured out the other amount. If X was 1, the other one was 24, 25 minus 1. If X was 5, the other was 20, 25 minus 5. If X was 15, the other was 10, 25 minus 15. So this is the amount I'm going to put in this other blank, 25 minus X. Now that we've got our equation set up, we're going to try to solve it. I'm going to first use kind of a clever use of the distributive property here. Since I don't want to use a lot of decimals here and deal with decimals all the time, I'm going to multiply this entire equation times 100. What that does is 100 times this decimal 0.10 just turns into 10. And so I can rewrite this first term as 10 times X. 100 times the 0.30 is 30. So I can write this second blank as 30 times 25 minus X. And 100 times the 0.15 is 15. So I can write this third blank as 15 times 25. So that's a real quick way to get rid of all these decimals so that we don't have to deal with decimals all the time. Well, let's go through this process here. I see some more distributing to do. 30 needs to multiply times 25 and times that negative X. 30 times 25 is 750. And 30 times negative X is minus 30X. Don't forget this plus 10X that was at the beginning. And on the other side, 15 times 25 is 375. I did these calculations earlier on a calculator, and you can certainly use Desmos or a graphing calculator to do multiplication like that. Now I have like terms to combine. I see a 10X and a negative 30X. Put together, those are negative 20X. Drop down that 750. On the other side of the equal sign, we still have 375. Now I see a number being added onto the variable side. Let's subtract 750 from both sides. Subtract 750, subtract 750. I have negative 20X equals negative 375. Well, we're almost to our answer here. We can divide both sides by negative 20. Again, it's fine to do these calculations on a calculator using Desmos or some kind of graphing calculator to find out what these are. So I only want to divide by negative 20. I don't want to divide by that X because I want to leave the X there. I want to divide this side by negative 20, and that does isolate this X. Negative 375 divided by negative 20 comes out to 18.75. Again, that's a calculation I did earlier on a calculator. So feel free to use a calculator to do multiplying, dividing, even simple subtraction and addition. Now, that's not my complete answer, though, because I'm going to go back and read that last question again. How many liters of the 10% and the 30% solution should she mix to get what she needs? Well, here's how I can completely answer this question. We just decided that X is 18.2.75. Remember, she's splitting that 25 liters into X and 25 minus X. 18.75 taken away from 25. So 25 minus 18.75 comes out to 6.25. So our final conclusion is that she is going to need 18.75 liters of the 10% acid solution and 6.25 liters of the 30% acid solution.